Hello, everyone, and welcome to another Data Science Lunch and Learn. Thank you for attending during the spring break. Sometimes we have to schedule to accommodate various schedules. We're really delighted that Meng Zhu, Professor of Marketing in the Pamplin College of Business, is presenting today. Before we get to Meng, there are two openings on the schedule, March 19th and April 30th. If you want to present a lunch and learn event or you know of a speaker, please suggest it to me, drop me a note. Meng has joined Virginia Tech last year in August. Prior to Virginia Tech, she was Professor of Marketing and Health at Johns Hopkins University. And she just explained to me how much nicer it is to live in Blacksburg, where you don't spend as much time commuting back and forth. And you have all that time to focus on research and grants and all that good stuff, right?
Yeah.
Her research focuses on causes and consequences to inefficiency and inequality, health and medical decision-making, and today's topic, human and AI collaboration. Looking at your research, Meng, I was really also intrigued by some of your work on urgency effect and prediction aversion, which, well, I think I know something about the urgency effect personally, right? It is when you start vacuuming the house instead of working on grading the homework. The immediate task seems more urgent and worthwhile to do than the more important but longer. Perhaps it takes longer. And also the tendency to be averse to prediction about one's future. Ignorance is bliss, right? It's moving to the future. So I'm looking forward to learning more about ourselves today from you, Meng, and human AI collaboration. The floor is yours.
Thank you. So admit more people. I think we have a lot of people joining remotely today, and thanks so much for still coming to the talk during spring break. All right. So I think one of my co-authors, Moritz, is actually joining from Zoom here today. This is joint work with Moritz, Jolene, and Yeli, in which we look at human AI collaboration from a behavioral perspective. Like Olivia said, my work is mostly focused on the behavioral side of kind of a substantial domain such as healthcare, medical decision-making, and more recently, human AI collaboration. I don't know how this room, the audience, would be familiar with behavioral literature on algorithm. Not much, I think you probably not. So there has been actually quite a bit of research on algorithm adoption, AI adoption from behavioral research. And the biggest kind of debate is, are people aversive to it or they are appreciative of AI? And the conclusion is it depends. So what we are interested in is not necessarily, are you going to be aversive or appreciative of AI per se? We're just interested in situations that might be helpful. Would you be interested in adopting instead of the general notion, I'm against machine or not? That has been done before, that people in general sometimes are aversive to AI from a behavioral perspective, because once they see them make mistake, they cannot get over it. Or in medical decision making settings, people think I'm unique. Whatever the AI is giving me, the recommendation, I don't think it's going to fit my unique circumstances. So we basically do not take a side of the debate. Are they aversive or they're appreciative? The point we are trying to make is AI has been shown as a promising collaborator in many of the domains, and especially domains what we are interested in are that are socially and personally consequential. For example, classification of liver cancer. Raise your hand if you think this is important. I think all of us would agree, right? Because there has been other research on domains such as music tastes or movie recommendation or fashion recommendation. But I think what we are focusing on is really domains. It's like a yes or no answer. Tell me what is this. Am I going to listen to you? And they're going to be really, really important domain like medical diagnosis. And here, this is a recent research published in one of the Nature Open Science medical journal. What they've done is they looked at classification of liver cancer into two types. I'm not going to pretend I'm an expert in liver cancer. My parents are both doctors, but I choose not to do medical research. But the key thing here is it's a or B, there are two types. You're going to see an image, and then you're going to categorize it into one of two types of liver cancers. And they've done it with 11, we will call it pathologists, and they're all different level of specialty. These trainees, of course, are less experienced, but you also have specialists, and if you go down the list, they become real experts. And so what they did is they asked these specialists or pathologists to make diagnosis for 80 images. So you see images like this, they classify either A or B, these two types of liver cancers. And they did it twice, 2 weeks apart. The first time, half of it was assistant, half of them without assistant. 2 weeks apart, flips the order. Okay, so what we're looking at is accuracy level. It's with model, this is a deep learning model, and with assistance from the model or without. We're going to compare the accuracy level.
Or can I ask a question?
Yes,
Are
please.
those 80 images all pretty clear cut, or are there borderline cases, hard to classify cases?
I don't think they're all clear cut. Yeah, because you will see the accuracy level. If it's all clear cut.
How do you determine the accuracy if it's not clear cut?
Oh, it was not clear cut to human eyes, but I think there would be actually.
A biopsy or something?
Yeah, like you would confirm the answer. So there's a correct answer basically. And I'm going to show another example again. There's a correct answer. And what we are going to do in our paradigm, there's always a correct answer. So that's very important for our paradigm. So what you're going to see, I want to point out three things. One is the model performance. That's a deep learning model, the performance on those trials, and assisted, unassisted. Unassisted is the pathologist makes prediction, him or herself. And assisted is actually, you will see a diagnosis recommended by the deep learning model, and then you make a decision, you make a call. So it looks overwhelming, but I just want to point out the most important message. 9 out of the 11 pathologists, their accuracy level improved once you combine with the AI. In this case, a deep learning model.
Very experienced ones, they decline.
Yes, that is not surprising because their accuracy level is so high and the model is less accurate. So I would say, even from statistical point of view, they might not be improved just because of ceiling. Although you will see situations, I'm going to show you, even with very high accuracy level, it might improve. Depends on.
Would the specialist not be in a position to overrule the algorithm, said, I'm not listening to you?
Yeah, you can do that. You don't have to listen.
But it didn't do it. Otherwise, their accuracy wouldn't have been reduced. They took some
sure.
information from the deep learning model.
Sometimes they do, but other times they don't do. I don't think we can know exactly, but in our paradigm, our study, we know exactly. Did they overrule or not? Did they accept the recommendation or not? So the key message is most of them are helped once they combine with algorithm. Okay, I'm not going to overgeneralize beyond this because I think there are many things I do not know about liver cancer. But yeah, go ahead.
So what are the characteristics of the bottom two that makes the unassisted better than assisted?
Because their own accuracy level is so high.
But
They're so
what is the
experienced.
characteristic? Are they more experts? Do they have?
They're more
years of
experts.
Experience?
Yeah,
So
they're
those
more-
last two is
They're
because they.
extremely experienced. They are the most specialized experience.
So it seems, is that a fair conclusion to say that the machine learning will help the people with less experience because they get second opinion sort
I
of?
think our conclusion is a little bit broader than that, but I will try to draw some conclusion after one more slide, all right? I'm gonna show another example that is consequential, we believe, not only in terms of societal, but personal, also, in general, this is a domain that is very important with a lot of implications. It's forensic face recognition. You could think about example like this. Basically, the task is very easy. I'm gonna ask you, these are actually, again, experts. They are examiners of different level of specialty and expertise. So they're prepared, they're presented with pairs of images. The task was to really say, are these two of the same person, yes or no? Okay, so let's see. Are these two the same person? Raise your hand if you think they're the same person. Okay, what about this? Raise your hand if they're the same person. Okay. So this is actually the same person, this is not.
No, I got it completely wrong.
But it is hard. It shouldn't be easy. And these are actually experts. I took out many of the results, but these are the most experienced experts. These are the highest performing experts. There are other human examiners. They show data there. And they had at least 4 algorithms. Those are state-of-the-art algorithms. And what I'm showing you again is going to be, again, what they call fusing collaboration. It's like they put together the algorithms prediction and humans. Here, it's not a human adopted, they basically just averaged them together in this study. What you can see is this person is performing really well, this examiner. And if we combine 2 examiners, they perform even better, which is not surprising because there has been research before showing when you combine averages, wisdom crowd is actually going to increase the performance. And here again, it's not adoption. I don't decide whether I take your suggestion, they're averaging the performances. And what you can see here is one examiner combined with this model, which actually the average accuracy level is here, would really boost the accuracy level, right? Even the accuracy level of this person, of this model, probably is not as high, but the combined one is the best.
So if the models just give it a definite result, what they provide additionally?
They do. Actually, in this study, they did. They have a confidence. I think in this, it's probably a percentage likelihood. In the human, they did probably confidence too in this study.
And what is the width of the figure?
I have to go back and check, but it's basically average. This is averaged performances.
Is that variance maybe?
It probably is various. I want to just be clear about it, but I think it is. I think intuitive it is variance.
Do you think confirmation bias would play a role?
It will, definitely. We will get there. So what I'm trying to say here is I'm not trying to draw any conclusion where it's good to combine algorithm versus human. Just looking at some of the recent research, there's some conclusions we feel comfortable to draw. First, individual accuracy matters, right? If you're really, really accurate, combine someone else might not help at the margin, but it depends to what degree it helps. Second, it seems combined human AI could help, but again, it depends. But what we do feel comfortable saying is kind of related to some of the earlier points, and this is confirmed by the recent PNAS paper, is that combined human AI performance or predictions might help more when the errors are not overlapping, when their predictions are not highly correlated. So in other words, what we are trying to say, or at least I think it makes intuitive sense or mathematical sense, there's a Bayesian paper on human AI collaboration does show that when these 2 type of predictions do not highly correlate with each other and their error are not too overlapping, the complementarity would enhance performance more. Lisa.
So the AI in this case is deep learning. That means that it's treated as a black box. It just gives the output without an explanation facility.
Not in their studies, but in one of the Bayesian studies that I'm citing, they do, I think they probably was trying to enhance the performance by doing different tweaking and make sure they're Bayesian updating and so on. But the point we are interested in is not that per se. We're not trying to create the best mode of prediction. What we are interested in from a behavioral perspective to see whether people recognize complementarity, because it's intuitively and empirically supported. The collaboration between AI and human are most helpful when they combine, when they're complementary to each other. At least there's non-overlapping mistakes, so they can correct each other. And we are interested in really to see, do people recognize complementarity in the first place? Do they appreciate complementarity? If I recognize it, do I appreciate, like what you're saying, confirmation bias? It could be, I know you're really complementary to me, but I don't appreciate it. But even I appreciate you, do I listen to you? That's back to your question. I'm going to be assisted by a complementary machine, but do I overrule their prediction? So those are the three things we're interested in. And we want to say, what would happen if I gave you the chance to learn about a complementary and non-complementary supporter? What would you do when you have the chance to adopt one of them? And how would your performance be once you adopt them? And in order to do that, it's actually very hard. Before I show you what we have, the common question I get is, how do you define complementarity? Like, it's just so hard. And we all know that actually we are aversive to people who are different from us in general. We do not appreciate people who are different from us. That has been shown. Let's say in OB, like diversity is not appreciated. But the problem is it's very difficult to quantify. Hey, this is the chance this person could have helped you. They don't have settings like that. It's pretty broad. So we need to find a paradigm. I can clearly say, hey, look, you make non-overlapping mistake. This is the person who can help correct you. And the other person who make exactly the same mistake as you, and you don't really get any help. And on those trials, you can get correct. They confirming you don't help, but do you still prefer someone who confirms your correct trials instead of someone who actually correct your mistake? Unfortunately, the answer is we actually like someone who confirm our correct answers instead of someone who
we
help correct us.
We have that in the human cognitive neuroscience paper, the paper published in Nature Neuroscience find people tend to only agree to people who have the same opinion with us. And the brain only like activate when people agree with us, like ignore when people like have strong opinion, different opinion with us.
Yeah, exactly. But I think we are a little bit different from confirmation bias, or what we think is in general consistent with that, but we incentivize you to make the correct response. We see that they still just would rather suffer the experience, and we see it in a clear setting where it's costly. So here I'm going to show you the type of paradigm we have. Go ahead, Riza.
So for example, in machine learning, you could have a trade-off between type 1 and type 2 errors, right? So are there situations here where the expert decided, for example, it's cancer and the machine said it's not, or the machine said it's cancer and human said it's
That's
not?
exactly where we are getting. So instead of cancer or not, it's image classification test. This article, my co-author Moritz actually find from NAS, they had 4,800 images. So they're basically noise distorted images. What's really amazing about this paper is they had human performance and model performance, and they clearly identified situations where human can identify it, machine cannot. But they're also opposite, machine can identify, human cannot. For example, let's look at row B first. What is this? The first picture.
Car.
Excellent. You're human. What about the second one? Third.
Shelby Cobra.
Some kind of.
All right, third one, fourth one.
Cat.
Cat, fifth.
Cat. Bear.
Okay, last one.
Bear.
Okay, yep, doing pretty well. Now let's try row A. What is the first one?
Jungle.
All right. Second one.
Ship. Sailing.
That's not bad. Third one. You're confirming you're human, not AI.
That's what my dream.
Smoke. Smoke.
Didn't want to put it.
Science.
It's experimental.
Depends on what we eat before the sleep.
Fourth one. Or whether you eat a steak versus tuna today. Fourth one.
We see everything as a Edible animal.
I don't see anything.
Okay, so let's just agree, these are hard trials, right? We can't really see, but these are really easy. But what's amazing is machine can actually fail on these. Machine cannot tell these, but human, you don't need help. You know what these are. And this ones, machine can easily recognize it, but we can't. And these are the answers. So you did pretty well for B, right? And for A, those are hard. I would never know it's all.
Bird, boat, bear, oven.
The point is, machine can do it. So
You have the non-noisy picture.
I think we could find those, but I'm not matching it, but I think they have the, probably they would have it. Actually, that's a good idea. Maybe I can match them so you can really see. So now we have exactly what Risa you're suggesting, a set where machine are good at it, human are bad at it. And it's amazing because they're trained differently, they process differently. So you actually can find exactly complementarity trials, right? Like these are machine trials, you could say it. These are human trials. And you all are human, we confirm that, which is great.
Do you have any information about the training that went into recognizing these images?
For the images, they do talk a lot about, I can send you the paper, it's a Stivers paper. They had a Bayesian learning model, so I think they definitely had a trainings into it. But it's amazing that they were able to identify trials where they created situations where one is some category are good at it and the other one fails. So
Is it supervised learning or unsupervised learning? In other words, do you have human taggers for all of them? Or do you not have human taggers? Is it classification or clustering?
it's a classification, like they classify it.
So unsupervised,
Uh,
do you have a human?
a classifier, and they are humans performing. Again, that goes back to the earlier question. I have to go back to check exactly how they train the machine model, but to our purpose, all we need is these images. So we can clearly say, this is human trials, these are machine trials. So this gives us really a chance to answer or ask this question. Would you be able to appreciate or ignore or neglect complementarity partner versus non-complementary partner when you have a chance?
So if you can go back to the images, if, for example, your deep learning algorithm has a lot of pictures on the part up, and then it learns from those pictures, right? And then later on, you come back and give a similar picture to, let's say, second column on the first row, and it knows it's a boat, right? So based on those characteristics, chances are that later on it can classify it as a boat.
That's a good question. I think the purpose was trying to say, they actually try to create machines that do not correlate with your prediction. I'm oversimplifying it, but it was trying to say, make sure you have non-overlapping mistakes. Then
I
when you
think
combine
the
them,
point is that we now have a set
yes.
of data points where we know the machine is better at it than us.
Well, like I said, I want to see that. I mean.
I will
happy to
give you
do
the
paper.
paper,
I want to
yeah.
see the training first. right?
Yeah, that's fine, but to our purpose, we're all set. Again, I love to hear computer science, read the paper and tell me, what do you think? Because for us, that was amazing. That's all we need.
So I just kind of one answer to the question you keep coming back to, whether, I guess people in general or the average person likes to be confirmed or not. I would say, like, if I had to pay somebody to give an opinion, then I wouldn't pay somebody to always have the same opinion as I have.
All right, let's hold on to that question because I think that's a judgment question. We're trying to describe what happens first and then go to the judgment part of it. All right. So we are creating a paradigm with those amazing pictures, giving them a chance to learn about two partners. One is complementarity, one is non-complementary. And we give them a chance to pick one to help them. All right. They only get to pick one and then make incentivized trials working with the partner. They get paid. And we incentivize them to choose the one who can enhance their performance. And we see which one they choose and to what degree they actually was helped by picking or hurt by the partner. So this is our paradigm, 10 trials. These are basically observe two partners making predictions, and you make your own prediction, and I give you the correct answer. So you can clearly know what the correct answer is and how the two supporters performed. So this is how the classification task works, right? So basically, what do you see in this photograph? It's a clock. Actually, it's a pretty human trial, and we ask you to pick one. And you can see, in this case, it's a trial, both human and the machine can perform well. They both say clock, and the correct answer is clock. And I probably said clock too, because it's a human trial. That's pretty easy. You also have trials like this. This is car, which is very easy for me. The correct answer is car. Supporter A is more human, non-complementary trial like me. But the machine, if you think about it, complementarity, supporter actually got this thing wrong. The machine said truck. You also have a third type right here. I would not know it's bird. I would not know it's dog. The machine, the supporter B, complementary one, actually know it's a dog. And the correct answer is dog. So I have 10 trials like this. You learn two supporters. You can clearly see one of them is making exactly the same mistake as me or cannot help me correct my mistake. But on the trials, I clearly know myself, the person got it right, the supporter got it right. But the other supporter, which is kind of weird, like on trials, I can easily get it right. I don't really need help. That's important. I don't need help on the trials I can get correct. If I need confirmation, there's a value to that, right? Because sometimes I'm questioning, am I right? No, you are right. You shouldn't question yourself. Confirming it doesn't improve your performance.
So, so the subject first made the first choice. When they see other partner's choice, do they make the second choice again or no?
They don't, but they know the correct answer. In the real trials, they basically see the supporter's answer and then they make
So
their own
directly
choice.
correct answer. And,
Mhm.
okay, I see.
Yeah, that's in the real trials. This is the learning trials, basically. And then they choose which supporter they would use for their real predictions where that's incentivized, right? So there are 10 trials and we're gonna pay you 5 cents. We spend a lot of money on this, thousands, 10,000s of dollars, I think, because we run a lot of studies. But the good thing is we got pretty convergent results across all the studies. And then they basically make 10 incentivized trials after they pick a supporter. So we ran a series of studies. The first initial study, we varied the accuracy level. This is the percentage the non-comparative supporter, you can think about another human got right. Versus this is the machine accuracy, and we vary 50-50, 40-50, 60. And then we did 2, and then in the other studies, we did 70-70 accuracy, basically 3 trials, both of them got right. And then the other 6 are totally now, sorry, 4, they both got right. The other 6 are totally opposite. So these trials I got right, you got wrong. And this is exactly here, like for this 6, I got right, you got wrong, or you got wrong, I got right. So it's exactly non-overlapping mistake for those trials. I'm gonna show you the first study. Basically, we varied. What time is it now? I think.
1:00.
Do we still have time? Yeah, we have
30 minutes,
30.
if you want.
So here, we basically had 10 trials, and then the non-comparative supporter, you could think about as another human, basically, just like me, got 6 right, and then the other supporter got 4 right. Again, no overlapping at all, or 5-5, or 4-6. And then we ask them to pick one, and then we see how they perform. Any questions on the paradigm?
How did you vary the accuracy?
Huh?
How did you vary the accuracy?
It's basically how many humans got right, how many human trials are there versus how many machines are there. Because basically for the human trials, I can get it right. For the machine trials, I get them wrong.
60-40 and 50-50 doesn't seem like a big difference.
It's not big. We did have a 70-30, but if it is too big, then you might, I don't think it helps us to create a 90-10. trial, right? Like,
No,
we could, I mean, the only thing we are worried is, are you trying to make the machine 90 or human 90?
I'm trying to make them as opposite of each other as possible, so that wherever I'm as human,
This is as opposite as possible. This is 100 opposite, because it doesn't matter the accuracy level, it's 100 opposite. Because on the 6 I got right, you got wrong. On the 4 I got right, so it's always 100% non-overlapping mistake. It doesn't matter about the accuracy level, it's entirely orthogonal. But we do think it's important not to make the machine too bad, because they, oh, this is really just helping me in 2 trials, right? You still have to learn they can do at least half of them right, or a decent amount right. So there would be boundary condition if they're only helping me on 2 out of 10. So we think it's important to have a little bit.
I think that he makes a very good point, but if it is 90-10, I think it would be deterministic for human or deterministic for machine. Whereas
depends.
if you make it 60-40.
hence the importance we attach to the decisions. Now, if all 10 images are the same, right, and the consequences of an error are the same, yeah, I agree, but some decisions are more important, impactful than others. So maybe, like in medical diagnosis, if I get this one wrong, it's a really, really big mistake. If I get that one wrong, it's not so bad. So
Yeah,
even
no,
at a
for-
90 and 10, the other ones where I need to be really, really sure that I get it right.
Yeah. So for example, if it is cancerous and the either machine or the human says it's non-cancerous, the consequence is severe.
It
If
is.
It is non-cancerous, and then, you say it is cancerous, you may shock them for a while, but then they go and get second opinion and they say
Sure.
that
I see your point, but I think the problem is if you only have one that machine got right, you got wrong, is they don't learn. Like you have to have some repetition to say that this machine can consistently get what you are getting wrong right? Like if it's only one trial, they don't really experience that at all. Like what you can see is even with 4 trials, 5 trials, they don't learn. Like we just think it's impossible for them to learn, like when the number is even smaller.
Okay.
Yeah, but we can make predictions. And also the other thing is, I think although normatively speaking, you're absolutely right. As long as the mistake is not overlapping, I should always pick the non-complementarity. I should always pick the complementary supporter. But we think people are affected by absolute accuracy, because if the absolute accuracy is so low, they just think this is crap, like you have to keep them a little bit above the crap level so they can at least appreciate it. Because it's like, how reliable is it if it's only but I see your point. So what we've done here first is we did a complementarity check to see, this is an objective measure of how often the supporter was correct when the participant was incorrect. And you do see the supporter A, which is non-complementarity, is actually non-complementarity, where the complementarity supporter could have helped you more. So this is confirming, based on their actual performance, one supporter is complementarity, the other one is not complementary. All right, so this is the key dependent variable we're interested in. We're interested in percentage of people who choose the complementarity supporter. Like what Oliver said, you should always choose a complementary supporter because that helps you. But what about the reality? If it's 50-50, 40% of them choose the complementary supporter. If it's 60-40, even with 60-40, less than 30% choose them. And with 40-60, 50%. So my colleague and I had a long debate about this. How much do we want to make a big deal about it? Because you could argue there's 0 reason for you to choose a non-complementary supporter, like logically speaking or mathematically speaking. On the other hand, what you said, confirmation bias, there's still utility. So maybe there's some utility in you choosing complementary supporter. But I think we just are totally not making any baseline prediction. We're just saying there shouldn't be a preference for the non-complementary supporter. That's our baseline.
Yeah, I was gonna say, I'm kind of puzzled now by what you said earlier, right? That the complementary was always basically the opposite of whatever. So then there's basically zero information, right? If somebody always has the opposite position of what I have, then.
It doesn't have to be, because we do have studies where there are 4 trials, both of them got right. So we're just saying on on some of the trials, they're entirely opposite. But we do have, in later study, we have 10 trials, 4 of them, both of them got correct. And then there's 3 trials. You got right, I got wrong, the other one the opposite. So it's not necessary
Always
always.
the opposite. It's the opposite when I got it wrong.
Yeah.
That's what I want.
Yeah, of course, but I don't. One earlier question, I kind of,
Yeah,
the answer was like they were always complete opposite, so then there's no extra information, right? Because there's 100% negative correlation.
but there's still
I can guess-
information,
I can
right?
guess the opposite of my own answer.
No, but
myself.
that's not the case, because there are 13, right? Like, look at this picture here. You cannot guess it, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
Okay,
So
it
you
wasn't-
cannot.
no,
It's
so
not a
the
yes
case
or.
was- Yeah,
And so there is
I
information,
just had another
Yes.
answer. That's.
but that's a good question. I didn't realize we have such a good feature here. But even that, right? Like, you're going back to the why part, right? Like, are they machine just give me these answers without me knowing why? But if they can just give you the right answer, even you not knowing why, it can still help you. But I'm not gonna go that far.
Yeah, that wasn't my point, but I think if there is just, you have a sequence of kind of different answers by groups, sometimes they overlap, sometimes they're not overlap. I think you can recognize the advantage of complementarity. But
Yeah.
if they would like just always be different, then it becomes more.
Yep, but no, I think your question is a very good one. I do think we don't have that issue, but the point I'm trying to still make is we don't know how strong the baseline should be, right? You could argue no one should pick this, or you could say maybe 50% is a normative baseline, because even you think like they're not the non-complementary supporter, I don't like it, or I like the complementary supporter. There's no reason for the complementary supporter to help you more. So you could use 50-50 random chance, pick one, but doesn't matter. What we see is really there's not many people go above 50% picking the complementary supporter. And what we also see is it is consequential. And what we find is once you pick the supporter, either it's complementary one or non-complementary one, we see consistently across all the accuracy levels that your performance is better if you picked the complementarity supporter. But you didn't listen to them all the time.
The math makes all sense. I mean, it's a very logical thing.
But people don't recognize.
What gets in the way? Our brains?
Yeah, like that's the entire area of behavioral science. So what's getting our way? Why people are not purely mathematical, Because, yeah, they should, right? And so that's what we find. And
You've proven that humans are unreasonable.
Predictably
There's
irrational.
lots of evidence.
The average test, I wouldn't generalize it that far.
I would say predictably irrational.
I'm not gonna make any. I've learned to tone down my statements. People say, well, we're not overgeneralize or overclaim. I actually get counter arguments. So I'm just saying this is what we find. In fact, we're actually writing up the paper at this point. So would be interesting to see, like, what do you think would be the way to position it? Because we're not overclaiming to say they're irrational. We're just saying it seems their performance could be improved, but they are not doing it. And so the next study we did was really, we did a lot of like variations to try to see whether you can get rid of the effect or are there any specific procedure thing that's driving our effect. So here, basically, we just show them after choice in trial or before choice in trial? Yeah, I'm trying to figure out what this means. I do not remember now what this means. Hey, Moritz, do you remember like what exactly? Oh, I think it's this
Yeah.
one.
Is that before they
So,
choose?
sorry.
Go ahead.
So after choice means that they made in their trial predictions, their trial to their classification, and then they saw on the second screen the supporters classification and the correct answer. And when it was actually not before, but it was during choice, so that they saw directly with the image also the supporter classification. And the yeah,
It's basically they see the supporters prediction.
while making their classification, yeah.
It's always before they see answer. Yeah, it's always before they see correct answer, but here they basically make their own choice. They see the supporter prediction, but here if they see the predicted prediction already when they are making a choice, I think it should be during. It's a better word, yeah. But that's the only variation we did. And here we didn't run a 40-60%. We only picked 2 of them, and it doesn't matter. The degree varies, but the pattern is similar. Again, we did a complementarity check. You do see that they could have been helped more by the complementarity supporter. And this is a percentage. It's pretty consistent. It's typically lower than 50%. So people do actually select the non-complementary supporter who make the same mistake as them more. So next question, and also before we go there, their performance could have been improved. You can see if they choose a complementary supporter, they perform better. Any questions on this? Actually, if you don't have a question, I will say one point about this slide here. No question about this? Okay, so one question you could ask, which I think is a very good question we got last time when I presented this in Utah, it was, is it possible that people who are smarter choose the complementary supporter, therefore they perform better? That's a good question. What do you think?
Are they statistically significant, like 6.89 to 7.25?
I think most of these are statistically significant.
So 6.21 as opposed to 6.17 is statistically significant.
Oh, these two, no, I don't think we're comparing these two. We're mostly interested in these comparisons, whether they select the complementary supporter or not.
That's very small difference, 6.89, 6.2.
So what this also says is they didn't really listen to the supporter all the time, even they are picking them. That's consistent across all the studies. They could have been helped more, but that's not small. To us, it's still maybe one trial difference. It's still important.
You have large numbers.
So we do have a very big number. It's always like at least 100 per condition. So if you think about cancer, I'm just saying, if one trial could be still consequential, or let's say it's forensic classification, that could be still important. So I think a valid point could be asked, are people who are not smarter, that's not the right word. You could also think about the other ways to classify them. For example, one is cognitive reflection. Are they more likely to reflect cognitively? Are those people more likely to select complementarity because they recognize them, and then they are more likely to perform better? So we actually ran a study last week at VT with the subject pool. Moritz, you have the newest data, right? Do you want to tell us what we find for the newest data?
Yeah, basically that it doesn't make a big difference if people choose the supporter or if they are kind of like assigned to a supporter. So the results remain pretty consistent, that people who work or collaborate with a complementary supporter perform better.
But there are situations that's boundary condition. I think that's where the accuracy level of the non-complementary slightly higher, then they have to choose a complementary supporter in order for the performance enhancement to happen, right?
Yeah.
But in general, we do find like at least for 50-50, once you assign, you still get improved performance. Like if I assign you a complementary supporter, not letting you choose it, you actually can benefit from it. But they're boundary condition. We're running more study at University of California, Riverside, because we think there might be difference between California students and VT students. We want to see whether their performance, what their performance will look like. So we'll have the data. I think that the data is almost in. We will be able to answer that question soon. But again, we don't want to overgeneralize. We've run this study with VT. We've run it on MTurk and also Prolific, which is kind of the European version of MTurk. And the reason we do not want to overgeneralize is it's possible that the absolute level of their performance level might differ across a population, and the difference might also differ. Like VT, maybe if I run an engineering department, the result could be different. So we are just not making any absolute conclusion based on at least the one result we have so far. All right. So the next question is the important one. You might ask, okay, what if I don't call it human, supporter A, supporter B? I call one human, one AI. Okay, will that make a difference? What do you think? If I label them clearly, this is a human supporter, this is the AI, do you think it will make a difference? It will? Why, Risa?
I would think that there would probably be some emotional, component in that. So for example, if I'm a surgeon, right, and another surgeon looks at it and give me their opinion, as opposed to a system give me opinion, I would regard it as two experts who give the opinion, whereas the AI is more supplementary, or like you say, complementary.
So do you think the neglect would disappear when I label it clearly?
Will has a comment here in the chat, that generally humans tend to trust humans, I guess.
Okay,
I would say, knowing what the task was, looking at images, and if I know that I can't see well what's in that image, I can't classify, I kind of don't expect another human to be able to either. So for that particular task, I would think a machine can do better, and I would choose.
so the
I would
neglect
be more
order.
likely to choose a complementary support if I knew there was an algorithm.
So you're saying the neglect would be decreased.
Yes.
Okay, so let's see what we have, what we
But
find.
that's because of the task you asked.
Sure. No, I think.
Because I
yeah,
would think that is a task that is very suitable to an algorithm to do well.
I think it may also depend on the perception of the human of what AI is. Do they have a propensity to trust AI, or do they have a propensity to not trust AI?
That's a kind of the opening question. We're not answering that question, but I think that's a point I think it's important to bring up at this point, maybe.
Will makes another comment, especially at the current state of AI's performance, this bias might change over time.
That's exactly true. We think there's some basic level of algorithm aversion versus algorithm appreciation that we are not claiming we're adding to this or saying confirming this or not. But I think what your question or your point was very important. We used one paradigm so far, which is image classification, and we are not trying to generalize it to anything beyond this. And we are actually very interested in looking for collaborators. The reason I'm presenting here is we would love to find collaborators who can help us think about domains where that could be more interesting or like beyond image classification to see whether there's complementary neglect, and we think there might still be, and even not, that would be interesting to show the cross-domain difference. And we are also very interested in debiasing. What can we do to debias the complementary neglect, which is some studies we show here. We're trying to basically debias them.
Autonomous driving is a very interesting case.
Yes, but how do you do
Nobody-
it?
Very few will say, I want the car to take over for me.
Yeah,
We don't trust that algorithm to do that, but we all appreciate any of the assisted driving capabilities that we have, the blind spot detection, the lane avoidance and all that. right? Interlock brakes. We wouldn't want to drive without them.
So in my
That's
group-
actually one thing we thought about, like our initial thought was autonomous driving.
so
But
in
it's
the-
difficult to program it.
in the human cognitive neuroscience field, there are large, like extensive literatures about this. So we typically use the stored, let's say, stock market.
Stock market prediction.
So it's like give you like a fluctuation
Yeah.
of stock. Then you can predict whether it's rise up
Yeah.
or down. And then they present subjects with some like expert, finance expert, and then subjects see their opinion, and then subject to see whether subject make. their
Is that
opinion.
wisdom of crowd literature?
Mhm.
Wisdom of crowd literature?
Wisdom?
Wisdom of crowd?
No, we
It's
don't
not?
call that.
Okay.
We call I don't know. how-
Confirmation bias?
Confirmation bias
Okay.
or the broad decision-making field. And then in that neuroscience paper, it presents subjects with a picture of a house, and then ask subjects to rate, to estimate the price of the house,
Right,
and then give their partner, they first made the prediction of a specific number. Then the partner will give another specific number, maybe could, but
right,
then you can see, you can use numbers
right,
to directly measure like
yeah.
the difference.
That's a great example because we basically have a table that I'm not showing you here because we're still working on it, but we're trying to say how our paradigm is different from previous literature. A lot of them are point estimates, and then you can
Correct.
adjust the point
Yes.
estimate, like how much is the house costing,
yes.
or like how much is this person weigh, and then you adjust the point estimate. And also some of them can
Binary.
give you a confidence
Yeah.
interval or
Yeah, yeah, yeah,
range, right? So we focus initially on classification task because we think it's very consequential, yes or no, right? Like it's just one answer, but we would definitely be interested in testing next point estimates and give confidence interval to see how the effect change. But anyway, so going back to what we have here, we actually did not see much difference when we did human AI labeling.
I think going back to the applications
Yeah.
of what you're doing here, I can think of at least two. One is detection of fake news. So whether
Detection of fake news.
humans can detect fake news better or based on some linguistic relationships, machines can do it better.
Moritz, are you taking notes? Sorry,
Another
think-
one is forensic accounting. You know, to what degree
Yes.
can, for example, earnings reports that are given or other information that are disseminated from the company is likely to be trustworthy or not, right? So
That's a
can
very
machines
interesting
look at
matter.
order of words or exaggeration in words or things like that to detect whether there is truthfulness in that context? And I think that the nice thing about doing it by machine learning or AI is because we have a lot of streaming data that is coming out, and no human can sit there and constantly, on a continuous basis verify. But if you can build systems as part of a decision support system for streaming data, then at least it can filter it. And when, based on some probabilities, it can say definitely fake news or definitely exaggerated,
Yeah,
likely, not likely, and definitely true. If you can come up with something like that, I think it can filter the streaming data that is coming at us so rapidly these days, and that would have significant applications.
thank you. Yeah, and I think autonomous vehicle is another one we thought about, but the problem we had was the decision has to be made so fast. They probably don't have time to think about complementarity, right?
I think by choosing a vehicle with assisted driving capabilities, we've already made that choice.
Okay.
We want that.
Mhm.
And if you were to take my ABS away or my blind spot detection, I would be a worse off driver.
Yeah, okay.
We've already accepted that, but I have not accepted an autopilot,
Yeah,
hands off for more than 5 seconds and
right. So it's different level of.
Different level.
Yeah, that's interesting. Yeah, we will talk more, and we think that's a very consequential domain that we would be interested in exploring more. And what you said about counting, that's another. I think it would be a very important domain to study. So the next thing we did was trying to get rid of it because we see complementary neglect pretty consistently. So we're trying to get rid of it. We did it in several ways. Before we show that, I want to mention another study. This study basically, so one important feature about earlier trials is this human trials are very easy for human to recognize, right? Like I know for sure these pictures are clock or not. So we actually make the human trials difficult. So these are still trials, human get better than machine, but they're relatively hard for human to get it. It's not like for sure I can get it. So once we did that, basically you're making the human trials more complementary to you too, because the human can help correct you more, which you should appreciate slightly more. What we find is actually when you make the human trials more complementary, actually decrease the choice share. So when the human are become different from you, you appreciate it less too. You're not appreciating the human helping you. But again, we don't want to overgeneralize it just because there's a lot of things going on here. So the point is when you make the complementarity, non-complementary supporter more complementarity, actually it decreases a choice share. And we measured performance or competence level. So how competent do you think the supporter is? We do find that actually mediates the effect. So you think the complementarity supporter is less competent because they make different mistakes than you, which is interesting. And I'm just gonna skip through the last two studies because we only have 1 minute left. Basically, what we find is you have to hit them really hard. You have to say, hey, look, this is the summary table. Look at the performance. And how complementary do you think they are? Only when you do that, that's the ones we get the percentage of people choosing complementary support at more than 50%. And what we can summarize confidently is people seem to neglect complementary in this setting. And that's not helpful because human AI collaboration is mostly helpful when they are complementary to each other. That's
Did
it.
you ask the machine which human they would like to?
We should do that. But that one of the conclusion is actually you should not create machine that learn from human. It should learn from another system. So you're complementary to each other. That's one of the conclusions from the
Yeah, because in supervised learning, the human provides the tags, right?
Exactly.
So in this situation, the human, when it's not a pattern that is not recognizable by the human is not helpful.
Yeah.
So unsupervised learning.
It's more helpful. Yeah. That's it. Thanks to everyone.
Any questions from the audience online? I'm looking at the chat. You have a question or?
Please feel free to email me later on. Yeah.
Meng, this was fascinating.
This was very interesting study,
Thanks.
absolutely.
Yeah.
A lot of applications.
I'm hoping my co-author took all the notes
Always.
for the excellent feedback. Yeah. Thanks for having
you.
me. Really appreciate it.